Question number 3 is really a question of function transformations. And I do have to apologize. This question says if the graph of the function y equals f of x shown above is shown above, and I don't have that in this particular document. So what it is, though, is a graph. I will give you an example what that graph looks like. Alright, so pictured over here, I have this graph, which is y equals x to the third, or f of x equals x to the third power. And that's what the original graph that would have been shown above looks like there. Now, each of these different particular examples, A, B, C, D, are all transformations. They're actually all shifts or translations of the original function y equals x to the third. So what we need to see is that when you shift a function downward, you're going to be adding something to the x to the third, or subtracting in this case. When you shift the function to the right, you're going to be subtracting. And so the first one, assuming that the numbers are shifting 1 to the right and 2 down, it would be the equation of that, given f of x is the graph on the right side, would be f of x minus 1 minus 2. And so that's not what we're looking for. The second one would be f of x minus 1 plus 2, because we're shifting it up. So if it's shifted to the right, you're going to have a subtraction. You're going to minus 1 or minus whatever inside the parentheses. If you're shifting it down, you're going to subtract 2 outside of parentheses. If you're shifting it up, you're going to add 2 inside of parentheses. Now the third example is shifted to the left and then down. And so that is f of x minus 1. We shift to the left, we subtract inside parentheses. When you shift down, you subtract 2 outside of parentheses. Sorry. When you shift to the left, you add 1 inside parentheses. So I've stated those two principles over on the right. When you shift right, subtract inside parentheses. When you shift left, you add inside parentheses. And then for when you're shifting up or down, the principle changes. When you shift up, you're going to add outside. When you shift down, you're going to subtract outside. So right is subtract inside, left is add inside. That's counter the way that we think it is. Usually right is add and left would be subtract. But when we're shifting horizontally, we move right, we subtract inside, move left, we add inside. When we're moving up and down, it works the way we think it should. When we move up, we add outside. When we move down, we subtract outside. So that brings us to the final example, which is shifted to the left and shifted up. So since we're shifting to the left, we should be f of x plus 1, and we can't tell exactly what it is, but using the example that's given above, let's say it was f of x plus 1, and then it's shifted up, so that would be plus 2. So that means that C is going to be our answer here. Now again, I'm saying shifting up and to the right, and it's not always easy to tell with some cases. So I usually try to fix a particular point and then visualize shifting it. So then if the point that I was shifting on the original function y equals x cubed was right there at the origin, then you can see that in A I'm shifting right and down, in B I'm shifting right and up, in C I'm shifting left and down, and in D I'm shifting left and up. So if it helps for you to make that fix a particular point and then follow that point around. Alright, so this is function transformations if you need to look that up in a pre-calculus book or another textbook.